What's up guys, it's Simon Fiaz, and today's video is on question 8th grade level chemistry paper 3 2021. Question 1, draw a repeating unit of this polyester. And ethanediolic acid reacts with it to form polyester. So C double bond O, C double bond O is a diol, O, and then I've got CH2, 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 O. Because it's got to have that COC. Ester. Spinning of polyesters biodegradable. Alkenes are not biodegradable. Polyesters contain polar bonds. See the one O. Polyalkenes contain carbon-carbon bonds, therefore non-polar bonds. Polyesters are susceptible to nucleophilic attack. Okay, can be hydrolyzed. Polyesters contain that bond. Polyalkenes contain carbon-carbon bond only, and polyesters are susceptible to nucleophilic attack, aka can be hydrolyzed. 1.3 calculate concentration multiplicity and minus cube of potassium manganate 7 solution. Sodium ethanediol is used to find the concentration solution of potassium manganate 7 solution by titration. The equation for the reaction is that the solution is made by dissolving this much of Na2C2O4 in a volume, making up 250 centimeters cubed. Okay, 25 centimeters cubed of solution, sulfuric acid isoconic flask. Mixture is warmed. Mean temperature is that. Okay. Okay, so first thing I would do is find out the moles of Na2C2O4. Even if I have no clue what's going on, which right now at the moment I don't know exactly what's going on. So I do that. Moles mass of MO. Milligrams to grams divided by 1,000. They're not going to trick us out. We already know the conversion. So it's going to be 0.162 grams over 134. Right? That's relatively easy for my first mark. 0.00121 moles. Right, then the second part, well then I've got the moles of that, Na2C2O4, right? So moles of this. I want to calculate concentration of the manganate, the MnO4 minus. So I need to divide that by 4, 0.00121, divided by 5, then times by 2, 4.84 times by 10 to the power minus 4. Using the chemical equation in mole ratio. So moles 4.84 times by 10 to the power minus 4, and that's of the MnO4 minus, right? Then what do I need to do? Well, I know that. Oh, that's tricky. So usually, generally, in exam questions, we're always timesing by 10 by scaling. But in this case, standard solution made by dissolving this much. I found out the moles of this much in water up to 250 centimeters cubed in a volumetric flask, and then 25 centimeters cubed of solution are done, and then titrated with potassium manganate. And I want to find the concentration of potassium manganate. So then I need to divide the moles by 10. Because 250 centimeters cubed to 25 centimeters cubed, so I need to divide it by 10. So I get 4.4 times by 10 to the power minus 5 moles. If I times it by 10, then it goes minus 3 divided by 10 minus 5 moles. Then concentration, moles of concentration, volume. Concentration is the moles divided by the volume, which is just going to be 25, right? No, but the mean titer. Why else would it give us the mean titer? Think about it. I need to use the mean titers. 3.85 divided by 1,000 0.00203. So first thing I do, convert milligrams to grams, find out the moles of this. Then use the stoichiometry, the molar ratio 2 to 5, so now divided by 5 times by 2, I've got the mole of this. Then realize I've gone from 250 centimeters cubed to 25 centimeters cubed of solution, so I need to divide it by 10, scale it down by 10. Then I've got the moles of that, then moles concentration, volume concentration, moles divided by volume. Why would they give us the mean titer if we're not going to use it? Let's be honest. So we are going to use it, and that's the volume we divide by 23.85 divided by 1000 to get the concentration. 1.4, draw the meniscus of the when the pipette is ready to transfer. So the meniscus should basically be like a curved line. So it's like this and then that, like a curved line. Then it says potassium manganate 7 is oxidizing and harmful. Suggests safety precautions other than eye protection that should be taken when filling the burette and dissolving the solid. Now when filling the burette, fill below eye level, and when dissolving the solid, wear gloves. Set the color changing at the end point of each titration. It's going to be colorless to pink. Colorless to pink. 1.7 figure 2 shows the burette containing this solution. Give 2 practical steps needed before recording the initial burette reading. Remove the funnel here. Ensure jet is filled / no air bubbles. Question 1 continues to the next page. When Na2C or C2O4 adds solution to this reaction, 6 or water ligands. Yeah, I can't go through that. Enthalpy and entropy changes, yes. How to influence free energy change, gives free energy change, yes. But I have not gone through ligands and all of that. Well, you know what, let's just go for it. Started the question off, and I guess this could be asking the mark. So stage 1, delta H. Delta H is negligible. So I don't know how you negligible. Make and break same number of bonds. Make and break same type of bonds. Yeah. Stage bonds have similar enthalpies. Stage 2, delta entropy change. Well, the increase in entropy, increase in particles from solution. Obviously, you need to know this equation, which I don't. Do this for marks. Increase in particles from in solution. Particles in solution. And then stage 3, Gibbs free energy change. Gibbs free energy change. Well, first thing I would do is what's Gibbs free energy change, how it links with delta H and entropy change and entropy change. Gibbs free energy change is delta H minus T delta S. Delta G is negative for forward reaction. Yeah. Then it says, yeah, I can't do question 2, not gone through any of this. Chromatography. Questions about ketone solution. X reacts with liquid ketones from a crystalline solid. Purified by recrystallization. Describe how the solid is separated and purified. Well, filter, dissolve in minimum volume of hot solvent. The reason we add minimum volume of hot solvent is because if we add too much hot solvent, we get an aqueous solution of the impure product in solution. And there's always those 1 markers that are like state why student didn't add too much hot solvent, or for example, or identify mistakes, and it'll give you a practical. So you do need to know all these small details. And then cool/leave to crystallize and filter under reduced pressure. Wash with cold solvent and dry. Then it says propanone reacts with weak acid HCN from hydroxynitrile, state the hazard associated with use of KCN, and then suggest why KCN is used instead of HCN. Well, KCN use hazard associated is toxic, right? A reason other than safety why KCN used instead of HCN is that HCN is too weak. HCN is too weak. Allan-Mechtern's reaction of propanone with KCN followed by dilute acid. Propanone. So methane, ethane, propane. It's a ketone, obviously. So the carbonyl group is going to be in the middle. And then what happens is the lone pair of electrons, C triple bond N, negative charge goes here, which is partially positive. That's partially negative, goes there. Then you've got this, where it's like, okay, I've got this here. I've got the CN here. And I also have the oxygen here with a lone pair of electrons negative, and then a H plus bonds to it, and then the final one, you form this. OH. And what is this called? This is called a hydroxynitrile molecule, OH and a CN group. I was going to ask about that. Given the equation for reaction of solid sodium bromide with concentrated sulfuric acid to form bromine. Now that's really important, because if it just said given the equation for reaction of solid sodium bromide with concentrated sulfuric acid, the first thing I would do, NaBr plus H2SO4 to form NaHSO4 plus a HBr. That's not bromine, that's hydrogen bromide. But it says to form bromine, so I'm gonna have to use the other one where it's like 2 HBr plus H2SO4 to form Br2. I already know I'm forming bromine because it tells me in the question to form bromine. Plus, what else am I forming? I know I'm also going to form H2O, and I'm also going to form SO2. SO2 plus 2H2O. Everything balanced. Obviously, you should memorize this equation by heart, which I think I've got it correct. Got the equation wrong. Let me check my textbook. Solid sodium bromide 2HBr plus H2S4 to form Br2 plus SO2 plus 2H2O. Perfect. What have they done in the mark scheme? Sodium bromide with concentration of sulfuric acid on bromine. Yeah, I think mine's perfectly fine. Not equation from HBr unless formation of HBr shown in separate equation. That makes sense because already it says the reaction of solid sodium bromide. Yeah, it does say that. So I'll give him that. It says solid sodium bromide with H2SO4 to form bromine, but I've just started off with HBr. But it does say unless the formation of HBr shown in separate equations. So I guess I could and then do that. Get the mark since I have shown formation of the HBr and that. And the observation orange. Yeah, orange. Give a reason for the use of each region. Explain the observation, give analytic equations for any reaction. Dilute nitric acid hydrogen solution, aqueous silver nitrate hydrogen solution, pale yellow precipitate forms, excess dilute aqueous ammonia hydrogen mixture, some of the precipitate dissolves, and darker yellow precipitate remains. Well, the idea, first thing, dilute nitric acid HNO3 removes carbonate ions or any ions that may give other precipitates with silver nitrate solution. Silver nitrate solution produces precipitates with chloride / iodide / halide. And then the two ionic equations, well, I've got chloride ions and Lingi ions, so I've got Ag plus aqueous plus Cl minus aqueous to form AgCl solid. Yeah, AgCl solid. And then Y is dilute aqueous ammonia NH3 dissolves AgCl, leaving yellow AgI. And then yes, so then final one, AgCl solid plus 2 NH3 aqueous to form Ag bracket NH3 2 plus aqueous plus Cl minus aqueous. So dilute nitric acid HNO3 removes carbonate ions or hydroxide ions that may give other precipitates with silver nitrate solution. AgNO3 produces precipitates with the chloride / halide. Produces precipitate with chloride / iodide / halide. And then the equation Ag plus aqueous plus Cl minus to form AgCl solid, or Ag plus aqueous plus I minus aqueous to form AgI solid. And then NH3 dissolves AgCl, leaving yellow AgI. And then the equation. It says, question 5, a mixture of methanoic acid and sodium methanoate in aqueous solution acts as an acidic buffer solution. The equation shows the dissociation of methanoic acid. Calculate the mass in grams of sodium methanoate that must be added to this much methanoic acid to produce buffer solution pH that. Okay. Already I can see like I can get a lot of values that I need. Well, by a lot I mean already 2, maybe 3. So first thing I know is that concentration H plus is 10 to the power minus pH, which is 10 to the power minus 4.05. I also know Ka equals 10 to the power minus pKa. You have to memorize these as well. So 10 to the power minus 3.75. I'm going to leave them like that. So what do I want to find? So mass of sodium methanoate. ethanoate, so it's that then, yeah. So I've got Ka, therefore it's going to concentration HCOO minus H plus divided by concentration HCOH. Do I have Ka? Yes. Do I have concentration H plus? Yes. Now do I have, yes, I can find out the moles of ethanoic acid. No, I don't even need to do that. I know the concentration of ethanoic acid 0.100. So perfect. Perfect. So therefore I can rearrange the equation HCOO minus equals Ka times by HCOOH divided by concentration H plus, which is, I'm just going to put it here, it's 10 to the power minus 4.05. No, that's dividing by that. So Ka 10 to the power minus 3.75. I just put my calculator. 10 to the power minus 3.75 times by 0.100 divided by 10 to the power minus 4.05. But it won't, yeah, 0.1995. What is that though? That's the concentration. I almost fall for that trap and that's the final answer. No, that's the concentration. Right, I want the mass. Well, then what I'm going to do is, I know moles is concentration of volume, so yeah, moles is concentration of volume, so moles is going to be my concentration times by 25 divided by 1000. Then I know that that's the moles, and then moles is mass over mR, mass is moles, times by the mR of sodium methanoate, which is 1 plus 12 plus 16 plus 16 plus 23. And then I get my final answer as 0.339 grams. 39 grams. Well, that was a bit tricky at the end. So I found a concentration H plus, find a Ka. Rearrange. You don't need to do moles and all of that. You've already got the concentration of methanoic acid there. You get that. But then that's the concentration of the sodium methanoate. I want the mass of sodium methanoate. Therefore, firstly I find out moles concentration of volume. Then I use moles mass of MR, rearrange it, mass and moles times by MR. Moles mass of MR, mass and moles times by MR. Yes, and then I get the mass in grams. Question 6. Give 2 reasons why apparatus shown in figure 4 is not safe. First reason is that flask is not clamped, and the other idea that bung is in the condenser. And what would that mean? Pressure buildup. Bung in condenser slash pressure build up. Flask not clamped, bung in condenser slash pressure buildup. Give one additional region that is needed to form any propanoic acid. Sulfuric acid. Sulfuric acid, phosphoric acid, nitric acid, hydrochloric acid, sulfuric acid. State 2 more mistakes in the way the apparatus is set up in figure 4. The direction of water flow is through the condenser. Yeah, that's not correct. Direction of water flow through condenser, we could say. Yeah, direction of water flow through the condenser. Thermometer is not needed. Look here. There's a thermometer there. That's not needed. Say the purpose of small glass beads to prevent the formation of larger bubbles. So let's start off from the beginning. Question 6.1, give 2 reasons why it's not safe. Flask is not clamped. Bung in condenser, therefore pressure buildup. Flask not clamped. Bung in condenser, therefore pressure buildup. One additional reagent that is needed to form any propanoic acid, sulfuric acid, H2SO4. Is 2 more mistakes in the way the apparatus is set up in figure 4. Thermometer is not needed. Direction of water flow is through the condenser. That's incorrect. That's a mistake. Direction of water flow through the condenser. Thermometer not needed. Say the purpose of small glass beads to prevent the formation of larger bubbles or to prevent bumping. State the name of technique used to separate propanoic acid from reaction mixture. Fractional distillation. Fractional distillation, and it says calculate percentage yield of propanoic acid. So first thing it says, student heats a reaction mixture containing this much of propan 1-ol. Propanoic acid separated as mass of that. Calculate percentage yield of propanoic acid. So percentage yield, actual yield, or theoretical yield. So first thing I want to do is find out the moles of propan 1-ol, which is the mass 6.50 over the MR. And it doesn't give it me, and that's why these questions are usually irritating, because they don't give you the MR. Propan 1-ol, so it's going to be propan, propane, methane, ethane, propane, C3H8. I get, and then obviously mass 60, the MR. Then what I need to therefore then use is then, because it's got a 1-to-1 molar ratio, therefore moles of propanoic acid equals 6.5 divided by 60. Then I can work out the mass, because moles is mass over MR. Mass is going to be the moles, 6.5 divided by 60 times by the MR propanoic acid. Propanoic acid, so obviously example of acid, a carboxylic acid, so methane, ethane, propane. So you've got your COOH, methane, ethane, propane. And it's going to be CH2 then, yeah. So 12 plus 12 plus 12 plus 12 plus 2 plus 12 plus 16 plus 16 plus 1. I get, no, that's not right, is it? Propanoic acid. $74. I typed into my calculator guess wrong because I typed in so fast. So yeah, that is correct though. CH2COH. I get 74. 6.5 divided by 60 times by 74. That gives me 8.0167 grams. Then the final step is to recall the formula percentage yield. Actual yield over theoretical yield. Theoretical yield times by 100. And what is the actual yield? So it's going to be 3.25 over 8.0167. I just keep it in the calculator, times by 100. 3.25 over my answer, times by 100. And I get 40.5%. State 6.6. State a simple chemical test that distinguishes propanoic acid from the propan 1. What's propanoic acid? Carboxylic acid, right? What's a propan 1? It is an alcohol. So I could use loads of tests, I guess. Like when I mean loads, I mean I could use acidified potassium dichromate with a propanoic acid, no visible reaction, no visible change, and propan 1-ol orange to green. Or I could use the one that's probably more common. Add sodium carbonate, propanoic acid, effervescence. No, why is it not going there? Add sodium carbonate, effervescence. What does that mean? Slash bubbling, and then propan dash 10. Don't just say nothing, say no visible change. Yeah, that's fine, no visible change. So add sodium carbonate, effervescence, no visible change. And that is the end of section A.